Good afternoon, everybody. This is Paul Giobbi. I'm the president of Zumasys, and I wanted to take a moment to thank you for attending today's webinar. We know that you're all extremely busy with technology projects and business needs, and it's a great honor to have you join us today. For those of you who don't know us, Zumasys is a technology company based in Irvine, California. We started in the infrastructure business. We moved into cloud computing about 10 years ago. But we have rich heritage in the multi-value PIC market, and many of you have noticed that in the last couple of years we've gotten into the software business, acquiring Accuterm, HBase, a number of tools from the nerdery, as well as distribution rights to OpenQM. Just so you have a little context, Zumasys is roughly 100 employees. We do 26 million in revenue. And we have PIC developers that are direct employees spread across the country. We are devout and committed to multi-value and making sure that these applications continue to thrive and have choices in terms of databases and development tools. I also wanted to take a moment to tell you that we're encouraged by the 100+ people who signed up for today's webinar. It's been a long time since there's been some excitement and buzz in the multi-value space. We did a multi-value market update last week that had even more attendance than this, and we're very excited about the options that are in front of all of us in multi-value. There's a new development world out there. We're going to refer to it as Web 2.0 today, and it's allowing us to realize that PIC applications are a little more mainstream than we thought, and there's some amazing tools out there for us all to leverage. So with that, we'll go ahead and kick off. This is just a brief visual on how Zumasys got to where we are at today. If you've been in the PIC market for a long time, you probably remember a gentleman named Tom McTeer in the Computer Clinic who did tape drivers and a variety of technologies for PIC. We got together with Tom early on after we started. We launched our cloud platform in 2006. In 2012, the most pivotal thing that happened in our company is we made a decision to give away 1% of our revenues to people in need and nonprofits. And we're closing in on our $1 million goal of supporting folks, and this comes directly from your purchases with Zumasys, and it's part of our goal to be kind of a more conscious-driven business. Again, there's some visuals on there as to when we acquired Accuterm and QM and HBase. We also are a very avid and strong D3 partner. My partner, who I started Zumasys with, came out of that space, and we love D3 and are still very loyal partners with Rocket Software. So that's a little bit of who we are. I always like to start off with kind of three visuals that unite all of us in the PIC market. And the first is this concept of your application as a workhorse. And if you attended last week's webinar, we're not going to repeat the same content, but we want to kind of set it up with these same three visuals. So as a workhorse, your PIC application is customized. It's really bent to the needs of your business. You probably purchased it 30 years ago, and you've already paid the software fees, and all you have is a small annual database maintenance fee with somebody like Rocket or Zumasys. That's the good part. The bad part is because this app has been so affordable to run, there's this concept of an IT debt, or this workhorse concept where PIC is almost underappreciated, perhaps by some of the new folks coming into the environment, whether it's a new next generation owner taking over the business, or somebody acquiring your firm, or somebody who just looks at it and says, you know, this is old and antiquated. So this is the first concept that binds us all, is we have these wonderful apps, but perhaps they're not thriving or enjoying as much mind share as they should, considering how much the value they drive for your organization. The second concept is, you know, if you look at the small screen at the bottom there, most of our applications look like that. There's menus, they're character-based, and you're hitting them through a terminal emulator. And at the top is really what we wish they would look like, as long as we could have the same speed and customization. And the top is a shot from a NetSuite screen. All of us continue to struggle with the user interface challenge around PIC, and that'll be a major thrust of what we're going to talk about today. Very powerful apps, but we all wish they looked a little different. And the last challenge that we all struggle with is really the aging out of our developer population. We have many customers that are in rural areas and their PIC developer has retired, and sometimes that's a catalyst for them to make a decision to move off of PIC, which is very unfortunate. So Zumasys has done a number of things to kind of stem that tide, and we talked a lot about that in our webinar last week if you want to watch a replay of that. We also have taken measures into our own hands. Over the last 6 years, we've hired all of these employees, with 2 exceptions. They're all full-time W-2 employees, and they're PIC developers that are really experts at what they do. They're available to do contract work, and as fast as we hire them, they get consumed, which is a further indication of this developer shortage. We don't think this is a long-term solution, but it certainly has helped us stem the tide. The long-term solution is really about bringing new talent into the market, and some of the concepts we're going to talk to you about today will actually facilitate that. So before I turn it over to Patrick, who's going to be our presenter, I wanted to have you do a little self-reflection. Are you a character shop or a GUI shop? I would propose to you that probably 80+% of the PIC customers out there are character. And if you think about it for a minute, the rest of the computing market has been through some pretty major transformations. The client-server revolution, which was really initiated by Microsoft, was really the last major replatforming we've seen on apps for 20+ years, when in reality these replatformings usually take about every 5 to 7 years. So we're due for a change. The good news is that most PIC customers skipped over GUI and client-server. It's good and bad, right? Many of us implemented supplemental things like DesignBase or Accuterm GUI or System Builder or a variety of different technologies, and those have pros and cons. But if you think about it, the vast majority of the market is in character mode. They've skipped over this inefficient thing called client-server, and they're prepared to do something new, which is, I think, a good thing. And if you really sit back and think about the kind of the next wave that's happening, Credit Suisse calls it the most significant, replatforming in databases and application architecture in 20 years. And what they're really referring to is this concept that the browser has gotten strong enough to do things like Google Docs, very responsive, quick applications. GUI doesn't need to mean slow. We know that many of your users type ahead several screens and they just need speed and efficiency. You can achieve that now with the strength of these browsers. And at the core of all of this are all of these software as a service companies. These SaaS companies probably already exist within your portfolio. There are things like Salesforce.com, Workday, Concur. There's just literally thousands of them. At Zumasys, I think we have 52 different SaaS applications we run on. And these browser-based applications are driving new standards, which Patrick's going to talk to you about today. So to some extent, we're really well positioned to take advantage of this concept, this Web 2.0, and this concept that the browsers are strong enough to really accommodate what a PIC user needs. And we believe this is the future. And we believe the future is about not being tied into a proprietary development standard that requires you to stay on a particular database. And we've recently introduced RESTful services, and we've made it available for free on our database, which is HBase, and we've also made it available for all the databases at a very nominal fee. It's about independence, it's about options, and really taking your applications forward, and Zumasys is leading the way in that regard. Again, I think in closing, you're in a position where you can leapfrog and take advantage of these new technologies, and what I'm particularly excited about is the fact that Patrick has a background in doing this that spans older technologies like .NET and also takes advantage of newer technologies such as Angular and these web platforms. Patrick, by way of background, comes from one of our largest D3 customers. They had about a 350 user license, but they had thousands of users coming in through a full .NET interface, and then recently made a decision to go ahead and switch that over to Angular, and that's when Patrick joined Zumasys as a technical evangelist. So with that, I will leave you in the capable hands of Patrick, and just thank you again for your participation. And at the end, if there's anything we can do for you or any questions you have, feel free to chime in on the the webinar portal here, and we'll make sure they get addressed. Thank you and enjoy.
All right, well, thank you, Paul, and welcome everybody. Again, my name is Patrick Payne, and I'm the technical evangelist here at Zumasys. And as Paul was saying, I got probably 20 plus years of experience, probably being in very similar shoes as the rest of you, which is maintaining a large PIC-based multi-value application. And in my space, I had to do a lot of integration work, and I like to tell people I was pretty young when I got started, and I didn't know what I was not supposed to do. So I was very creative on getting the D3 system in those years to call and talk to stuff. So I'm now here with Zumasys, and I'm going around and both showing the technology and helping build new tools for the platforms to help us all move into the new world. So like the first hit is quite often what we're all experiencing, which is, the organizational concerns, which is, what is this PIC thing? It's hard to integrate. Nobody seems to know what it is. It seems difficult to manage by your classic sysadmins. It looks old because everybody sees these green screen or blue screen applications and think of being a DOS application. And with that, you end up with a lack or decline of resources. You usually have some senior developers, usually one or two, who've done all the work on the platform over the years. And so you find both your customers and your business associates kind of stuck in the middle. And really the big problem, and really what people keep pointing to is, well, it's not SQL. And PIC is not a SQL system. It's a very different type of animal. So over the years, when I was attempting to tackle this problem, I would go off and look at any of the new technologies and find what things were out there that we could utilize. And I've done probably what a lot of you have done, which is attempt to work through SQL or through ODBC interfaces, but it was never easy to use and was usually pretty non-performant. So what I like to do is let's first talk about really what we've been dealing with as a development environment, and what any developer that you were bringing in newer in the last, let's say, 15 years, what they were used to, which is this nice Microsoft Visual Studio based environment. And it's a very nice environment, and it's very tightly intertwined with the tools that they offer. And so you got your Visual Studio with their programming languages, which could be something like C# or Java, very object-based. But it's tied very tightly to a SQL-based system. And so all the tools in there, when it came from tying the UI to a database, was always expecting a SQL piece. And it was very tightly coupled. And we would come in as PIC developers and start trying to tie our applications into this layer. And normally we would tie in at two places. We'd either attempt to make PIC look like a SQL system through ODBC, or we would tie in with extension languages that the vendors would offer. And if any of you have attempted to do this, you'll understand these items, which is, if you go to the ODBC route, you find that PIC doesn't map very well. It's a very difficult thing to do. And why? Because PIC has features that SQL doesn't have. And some of those items are nested records. We're able to store much more complex record structures in one record. PIC does not have an enforced schema, and of course SQL does. PIC can actually store different type of schemas in the same file. PIC doesn't enforce any data types. That's with your schema. And I always like to say the classic, if you ever export data out to somebody out of a PIC system and they expect a field, for example, to be a number of a money amount, we could actually throw data in there, an alpha in there. And it's always a question, how do you guys do that? The real big issue you run into if you go ODBC is none of the optimizations or the way that those type of developers would think actually work well with PIC. So even if we do get it mapped, it doesn't perform the same because you're actually taking a certain type of pick structure, breaking it into this complex SQL structure, and then it's coming back together on the UA side. And so they usually just don't perform well. And the big item is you're bypassing the real power of the pick platform, which is usually our business logic. All the rules and code that was put into the system, that's all been bypassed when you just go straight through ODBC. So usually the better option was to go with direct integration. And that's where you actually extend the pick language over into the programming language that they're using on their side, for example, .NET or Java. And products that do that, you'll see on the U2 side, you have UniObjects. Over on HBase, we have our JAgent. D3 has its MVS toolkit. Bluefinity has its MV.NET product, which is a cross-platform one. And while these are great products, there's some big problems. And the first and foremost is that your UI developer still has to learn pick, because you're really just bringing the pick programming commands into .NET. So they're still forced to learn what arrays are and how our lookups and all that stuff works. Two is you're kind of tied to only the technologies that your vendor has exposed that to. And so it's usually just .NET and Java. A couple of the vendors have done a little bit to Python, but every 2 to 3 years there's a new tool in this space. And right now Node is a big popular tool. Ruby is very popular. So unless your pick multi-shop, your vendor ports something like UniObjects out to these, you're unable to use that technology. A real big problem is that your pick developers, your senior pick developers, are then usually unable to contribute, because many of these other environments, like a .NET environment, which are very class and object-driven environments, there's a steep learning curve, and most of your senior pick developers are going to shy away from that. They usually just want their AccuTerm window and their editor, and they want to code. So they find themselves unable to contribute. And on the .NET side, the current developer is still wondering, what is this? Why am I having to learn this other model? I have SQL tools. Why can I not just use my SQL tools? So as I've been trying to tackle this problem, I would really look into the new markets and see where the new technology is going. And this is where I get real excited about what's happened the last 4 to 5 years. And it's through the open source movement, and it's through the very large social technology companies such as Facebook, Google, and Twitter. And they were all handed an interesting problem where they had to build these applications, which are database applications, that would be worldwide. I mean, we're talking millions of users. And as they would try to scale up the technology they had available to them, which would be your Microsoft or Oracle or Sun type tools, they ran a couple problems. One, they were too expensive. Two, they wouldn't scale, and they were slow. So they actually used their resources and started using open source and tried to tackle the problem and find a better way to do this. And a couple really interesting things came out that really helps us. And the first one was the NoSQL movement. They actually went back and looked and said SQL is actually operating too slow for us. They reviewed what they were attempting to do, and they said, well, why don't we store data in a different way? And so this came out with a NoSQL movement. And this is where you'll hear popular ones like Mongo or HBase or Cassandra come out. And then, as Paul was saying, they beefed up the power in the browser to bring a very rich application. And as I talk about this, I think an important thing to throw out is, when I talk about where SQL is and where REST and these terms I'm going to throw out, this is at the place where they ran into a real fundamental change, which is once the browser was going to become more powerful and all it had to go do is retrieve data or call a function, they had to build a way to make those systems share versus just bringing perhaps SQL out and letting the browser directly access your SQL system, which they were never going to do. So this is where these new movements came in. And what really excited me about this is that they're all open. They're all designed to allow different systems to communicate back and forth. These are open standards. Nothing's proprietary. Most of these companies are using open source stuff and freely give out the tools they're doing this all with. So the community then continues to build the tools out. So the big thing here is, how does this end up helping us? And let's look at the technology pieces that are involved with this. And the big one is what's called REST. And that's why everybody is probably here as we talk about what is REST. And what REST is a way for different systems to share basically what I would call subroutines in our world, but it's basically allowing us to share our business logic and our data between different dissimilar systems, all using open standards. And so what you do is you look at REST, and it's a couple things. First, it's a way to exchange data back and forth. And if you look at any modern developers, they are developing in their languages such as C# or Java or PHP. They have an object concept, which is a data object. And I have an example up here for you to look on the left. And if you look at it, it's their ability to store a complex business document in a single variable or document or object, as it's called here. And if you look down, you'll see some things that should look familiar to us as pick guys, which you're going to notice that you have nested arrays in there, where I can say, hey, I can store multiple phone numbers. This thing can store a very complex invoice because it's got arrays and then variable types within arrays. So again, this is able to describe any type of pick record. Two, you'll notice there's no typing, meaning I didn't have to say that this was an integer or this was a number. Again, another similarity to pick. Three, the wonderful thing here is you can now take this one customer variable and pass it around to different functions. And then finally, they're able to extend it or modify it, add new fields to it on the fly without having to rebuild everything. So that's the core piece, is that this technology is saying we're going to exchange our data with objects. Now, what JSON is, if you look in the middle, is a way, it's basically an EDI format that allows any system to represent their object as an EDI record for passing back and forth between systems. Therefore, if I'm over here on the left programming in JavaScript, making my object, when I make a call to my back-end system, which could be in PHP, it could be in C#, it could be even in Pick Basic, to send that object over to them, I first turn it into this JSON object, which is an EDI file format. We send it. The other system is then able to take that JSON and convert it into its object structure, if it offers objects, and move forward. So that's the first important piece and really the foundation of what this is. And what's great for us is that the more complex object structure can describe pick data. The second piece they add to their object programming is the concept of methods, actions. I now have an object, I'm going to run and do some actions against it. And in REST, they said, look, let's take the standard 4 actions that you would do and make that consistent. And those 4 actions are, you're going to query your data, you're going to go get a record, you're going to save that record, or you're going to delete that record. And again, you're seeing here, and this is what really excites me, is that nothing in this model and nothing in this design really cares about what the back-end database is. You don't see anything here that's SQL specific. This is business objects, business applications. Then, of course, you have other methods. You would extend out your REST service and say, I may have validation. I may have error checking. But as you want to add other methods, you extend out the REST object model. Now, where I get excited when I look at this and look at the years of why we've liked our Pick platform and what our Pick platform does is we fundamentally were doing the same thing. And so I took that same exact demo slide and said, well, this is a Pick representation. Over on the left, even when I code a certain way, it starts looking very much close to object syntax. So here I am storing that same customer record in a Pick record. And this is the core of why SQL tools and ODBC tools did not work well, because you would have to take that record and flatten it out into multiple tables. In the middle, I show you your pick layout. This is where we differ because we don't have named fields, we have an array. But on the right, you'll notice that the actions that we traditionally do in pick line up almost exactly with the core actions that you saw on the REST side, which was we do a select to query our database, we do a read to read the whole record in, we do a write to write the whole record out, a delete to delete the whole thing. And then as we want to add logic, and this is where I said earlier the business logic that's in our systems, that we may actually go do some activity. If it's an invoice, we may do fulfillment, we might send out emails and other things. So those are your additional methods. So this is where, a core piece of the presentation is to show that structurally, and this is where we say what is old is new again, and maybe we were a little more mainstream than we thought, is that the model of what we were doing is actually the new popular model that's now propagating through the new development world. And again, all the power and items we liked about the model, which is the ability to add fields on the fly, no super tight typing, all those items is exactly what the new modern developers are looking at and what they're using with new tools. So let's talk about what this ends up looking like when it's actually being used. And what you see here is a classic of those 4 REST services running, and it's your 4 actions, what we call CRUD, create, read, update, delete. And I'm demonstrating it here with a standard web API tool that everybody on the developer side uses called Postman, and it's calling right into a pick REST service that's running directly off JBase. There's no IS involved, no .NET, no PHP. It's directly from the client right into the pick system. And if you look through, I have all 4 actions. On the left one, you can see we've done a query, and it should come back with a list of records. And again, if you look at the file, this is just an EDI file format. In pick, if you can write a pick program that can output that, or write a pick program that can read that, then you are doing REST. And then as we go through the other 3 boxes, you see the other 3 database actions. You can see right in the URL bar, they just put a slash and the primary key, and so now your pick program should return back just that particular record. If they change the web actions to delete, then the pick side deletes the record, and on the final one, it was doing a post and updating, which means it would have been passed in JSON, and the pick program would have gone off and updated our record. And what I would like to say is that, most of us have probably done EDI work, and in the reality, this is fundamentally what this is EDI work, but it's real time. Now, the exciting piece in all this, when I talked about the NoSQL movement, and this is really where we talk about how it helps and relates to pick, is as developers, we're learning that they're doing much more of their development in objects. And if I was to take those above slides and say, if it was a SQL-based system, they were now developing in exactly the same manner. They're going to build objects, and they're going to post objects to a REST service. But in their world, they would have then taken a .NET environment, take that JSON object, and had to flatten it out to SQL tables and query those SQL tables to put it back into an object to hand back. And so as UI developers are over here working on an application, they're thinking in object, or I like to say document methods, because that's how business works. They started getting frustrated with why they had to go over and do a bunch of work or wait for a SQL DBA to take those objects and flatten them out. And every time they would modify and add a new field, they would have to wait for the SQL DBA to turn around and add those new fields, rebuild the databases, and move forward. So what happened is they started asking, why can't we just save the objects directly? Why can't we just work in an object method? Why can't I have a database that can just save the object directly? And that's where you saw the introduction of what's called a document database, the NoSQL document database. And the most popular one out there is probably MongoDB. There's also Cassandra. But these are very popular systems that can scale really big. They implement much of the same concept as PIC, because remember in PIC we build a complex record and we save it, and all in the same methods. No schema, none of the items that that like SQL would have. They started using these tools and learning that the model, which again is pretty much a reintroduction of the PIC model, is actually a pretty flexible model. And the great thing for us is that the tools that are being built for this are open and work with PIC. PIC has, this lines up directly with what PIC is doing. So we can jump into this area. We're able to describe what we are. We're able to go and find developers and say, this is the type of system we are, and these are the type of tools we would use. So what the big item now is if we go in and we start building up REST services within our system, our next step is to build our UI. And the real exciting thing, and this was driven not just to us, this was driven into the .NET and those type of applications. As Paul said, as client server came out, they didn't, even in those environments, they did not always properly separate their logic. But this new model is most definitely requiring you to split your business logic from your UI. And what's wonderful is that once you build this out and you have a level of REST services on your system, you can now go out there and use any modern UI development tool to build a new UI talking into a PIC system, because these tools are just expecting a REST service. And again, this is a very important piece. So now, instead of having to use some proprietary, be it Accuterm GUI or Design Base or anything like that, you're able to go out there and get normal UI developers who can go off and use something like Angular, which on the left, Apereo is a web-based Angular app builder that will, through wizards and drag and drop, build most of the application for you. And you can see right down through the list, while it still supports SQL and SOAP services, the one we're going for is existing REST services. You tie right into there, you can call into your PIC platform. On the right side is Visual Studio. This is Microsoft's product. They saw the change in the market, and as Angular and these other systems were taking off and you were actually seeing that Microsoft was starting to get used less and less, Microsoft did realize they had a wonderful environment. And as long as they were to shift in and put this technology in there, that their tool would still be very usable. So they, right here, is where they call it web APIs, but it's the same thing. You click here, and it can now call into your PIC platform and get data back and forth. And again, once the services are there, no one's going to know that that is a PIC system versus a SQL system versus a Mongo system on the back end. Now, how hard is this? I threw in a couple of slides here because I've been asked is, how hard is this? Well, this is an example of the product that Paul was talking about that we offer, where this can be available directly in the PIC platform. And again, a lot of what I'm talking about here is options. So you can still go off and use .NET or use Java, call into your PIC platform to get your data, and then expose at a REST level right there and use their REST tools. That's an option. Another option you have here is you can actually write it directly in PIC. And this is not really a full RESTful service, but it's really more of a hello world. But it shows the coding just done right there in PIC Basic with the libraries that our product offers out. So you can sit in there and write your code. And if you were to actually ever write these type of things in PHP or Ruby, you're going to see very similar functions and commands, because there's about 10 things you do in the web, and you can see it all right here. You can access your headers, set content type, get the body. And a big piece we added in here was a object library. So if you're on a PIC platform that doesn't offer objects, we have an object library that helps you consume and build up your objects. And all you would do for a REST service now is extend a program like this out to say the person asked for a record, I need to go get the pick record and build the object. If they're asking to update it, we do it the other way around. Again, this is classic coding. I see some solutions attempt to do all this for you through wizards or automatic mapping, but as we know with most pick systems, that's tough to do. You're almost doing like what ODBC is. So our solution was more like the direction of Node or in those environments where we give you the tools, we give you access to everything within the REST and the web stack, and then you can build out your services and functions as you need. This is again back to the classic Postman app. You can see right here where I went in and built the objects that it was expecting as variables coming in, and in the bottom you can see the response from the pick system. So the real important thing here, and where I feel the whole world has changed now, is that the new world is open, and you get to use the tools at whatever area within the application that are best. You know, you don't have to say, hey, because I want a web application, I have to move off my pick system to get access to web technology. That's not the way the new world is working. The new idea is for all these systems to communicate with each other with a common structure of REST, and therefore you can use whatever tool is best for any place. So if you look at the new list, down the left side you see your development tools, and while Visual Studio is still a great tool, you can see that Microsoft's come out with something called Visual Studio Code, which is basically Visual Studio Lite. It's now available on Macintoshes, for example. But very popular in that space is things like Vim or Sublime or Notepad++ or our venerable Accuterm for doing your actual coding. On the database side, again, agnostic, whatever database you wish to use, including our MultiValue platform. So once again, SQL's still in there, wonderful tool for what it does. But within the NoSQL movement of document databases, that's where Mongo sits, and that's where our MultiValue platforms sit. The language, C#, excellent language. Java is still out there. Python is, I think, one of the most popular right now. But now you have Node.js coming up. All these languages can read REST and produce REST. And Pick Basic. Pick Basic is sitting right there as an option, as I just showed in the prior page. And again, that was tying back to your senior developers and saying they could be involved and assisting with exposing out those parts of the system because they understand it right now. The core of all this is, again, the web services. Open, common structures for talking back and forth between these systems. It's using HTTPS, normal web protocol. There's nothing proprietary there. You're able to buy third-party tools to do monitoring, add security, do load balancing. JSON is our data format, so we all have a common way we describe our data and or variables as we pass things back and forth. And REST is just the consistency of standards, because what I like to throw out here is to be honest, most Pick guys, if they were doing anything, were having to build their own web APIs into Pick over the years that were actually fundamentally what REST is, except for REST is, hey, we've all agreed on how we're going to do it. And what does that leave you with? Now you get the choice of UI tools to build your interfaces. You can still use Visual Studio and their tools. You have Xamarin, which is their mobile platform that Microsoft just recently purchased. You have React components, which comes from Facebook. You have Angular, which comes from Google. jQuery is an open source suite. There's hundreds of additional software packages out there. And as this environment has been maturing, you're starting to see some much easier, almost wizard tools. And again, everything in here is it's not some Pick specific thing. As I heard Paul say, you know, we're now using normal industry standard tools that everybody else is using here because we're exposing our stuff via REST. And then as we talk about integration, the real power of REST is those REST services are not just there for UIs, but they can also be used for system-to-system integration. Therefore, if you are an ERP shop and you've built invoice objects for both putting invoices in and out of your system for posting against inventory. Well, somebody else who comes in and wants to do automatic, hey, I want to use EDI, they can call directly into the system and use the same exact REST services. So let's talk about a roadmap. I like to, with my background and what I was doing with my shop, is I had a series of steps I was doing. Number one, utilize your senior developers right now to start learning how to build out REST services and get those systems mapped out. And tied with that is the most important piece, which is they've got to decouple your business logic from screens and make them standalone subroutines. There's no silver bullet to that. A lot of our PIC systems, and not even PIC systems, but other systems, have these tied together. You have to pull them apart. Once you do that, you can start exposing your business logic behind REST APIs. An important piece in this people ask me about is that there is a rethinking on how you lock stuff. Web stuff usually wants to be more pessimistic, so you need to start thinking through how you're doing that, and there's good white papers, and we're able to help you in those areas. Once you have that ready to go, you will actually find that you basically have coding templates on how you build your REST services. And I found that now when I bring in my newer developers, they sit there and work off those templates, and they can actually start writing the PIC side code. PIC is in BASIC. It's not a difficult language to code in. And what I actually found that most newer developers did not like about our PIC code was we had big UIs written in them. And they would look at them and go, well, I haven't had to write a UI in 15, 20 years. I'm used to a web technology or web form technology. So I never had to do that. And so that's the part of the code they hate. But I found that once I had these smaller data-specific PIC code, that they were fine. And if you get into certain versions of PIC like HBase and OpenQM, which actually offer objects and start offering some of the more modern commands and classes that they're used to, they even get more comfortable. And then start looking at these new UI tools. There are a lot out there. You can go through tutorials and webinars and see how they work and see which ones at the complexity level that you wish to be at work for you. You can work with an Angular or a Xamarin, which are a little bit more complicated but very powerful, versus going with an App Studio, which looks almost like Visual Basic from the old days, or Access. So in summary, I like to hit out a few big points here, which is number one, we've been able to identify what PIC is. And it's very important. We're a NoSQL document database, one of the most exciting new trends out there, which means we can utilize the tools and talk about what we are in reference to document databases. You can look at Mongo and see this is how a Mongo person would develop a database or a solution the same way we would, which is different than a SQL people. Most PIC code I will actually easily refactor into NoSQL type access tools. As I explained earlier, our structures were pretty similar with the CRUD concepts. Interesting thing as we talk about these NoSQL tools is that PIC is still ACID compliant, meaning we are certified for business applications. A lot of these newer Mongos and Cassandras are a little bit more social website design, and they are building ACID compliance into the applications, but within that space, we're already there. PIC has always been an ACID compliant platform, meaning that we're guaranteed when you write something to disk, it is immediately to disk. And then to look at the new application trends and keep these in mind, because I kind of tease that you don't want to be, moving to a big, huge DOS application just as Windows was taking off. And that's the same thing happening now. You may not want to jump into a big, thick Windows application when all the UIs are getting rewritten right now for Web 2.0. Also keep in mind what NoSQL is. Everybody's rewriting UIs right now because the idea is mobile first. Start to modify your development methodology. Look at how the new developers are working with agile methodology and new version control. Microservices is really kind of the term of what all this ends up being. We build services on top of our platforms, and they just get used by the end developers. And then getting into the big thing of machine learning and big data. There's lots of ways for us to push our data into these systems where they do the reporting. So that's the end of my presentation. I'd like to thank you for your time and interest in Web 2.0. Now, next I'll give this over to Corey, our VP of Strategic Development, who can give you some additional information and news. Thank you.
Well done, and thank you, Patrick. So now comes the call to action. And so as a call to action for ourselves at Zumasys, we will be sending a link to the recording of this webinar to the group that attended the webinar today. And then the call to action to the audience, and that's where to start on your MultiValue 2.0 roadmap. And that begins with emailing multivalue@zumasys.com in order to receive your free trial, 30-day trial of the MV Connect product. So again, multivalue@zumasys.com in order to receive your free 30-day trial of MV Connect. Thank you all for taking time to sit with us this afternoon and learn about MultiValue 2.0, and have a great rest of the day.